All right, so in this section we're going to be talking about prime numbers. And what do I mean by a prime number? Well, a prime number, the best way to express it, it's a number that has exactly two factors. And those two factors are always 1 and itself. So things like 2 is prime, the only factors of 2 are 1 and 2. 7 is prime, the only factors of 7 are 1 and 7. You can't break it up into smaller factors except 1 and itself. Now, it is just for convenience sake, but mathematicians don't consider 1 to be a prime number, because when we're talking about primes, it turns out that if you let 1 be a prime number, you'd have to make a lot of exceptions to some rules and to some theorems. So just to make things a little bit easy, we say 1 is not a prime number, and that fits with our definition of a prime having exactly two factors. And if a number isn't prime, and it's not 1, we call it a composite number. That's a number that can be broken down into smaller factors. Like 4, you can write as 2 times 2. 6 is 3 times 2. 24 is 8 times 3, or maybe it's 6 times 4, or 12 times 2, whatever. 25 is 5 times 5. So they're composite numbers. They can be broken down into more factors besides 1 and itself, which means all counting numbers, or all natural numbers, that's what we're dealing with here, are natural numbers. So we can say that numbers are either, so if n is an n is either prime, that has exactly two factors, composite, if it has more than two factors, or it's the number 1. So every prime number fits into exactly, every number, not every prime number, every number fits into exactly one of these categories. It's either prime, composite, or the number 1. So a good question is, now that we know what a prime is, how do we figure out what numbers are prime? How do we find prime numbers? And back in, let's say, the early 1000s BC, I believe, I'm not 100% sure of that, but there was a Greek mathematician by the name of Eratosthenes, and his way of finding primes, we kind of still do today. We've made a few improvements on it, but not anything really mind-blowing. So let me show you what he did. And it's basically exactly what you'd think. So you take your smallest number, that's going to be prime because it doesn't have any smaller factors. So you start at 2, that's going to be prime. And you cross out every number that is a multiple of 2. So I'm going to just color these in with black to say that they are not prime. So 4 isn't, 6, 8, 10, 12, 14, 16, 18, 20. You can see all of the even numbers here, and they're organized in groups of 10. So I'm just going to do this. In fact, maybe I'll make my pen a little bit bigger. There we go. So all of these guys are not prime numbers. They all are multiples of 2. So they have 2 as a factor. So we're not going to include them. And you could imagine there's nothing special about 100. You could do this with any number of numbers that you like. So now that we cross out all of the multiples of 2 in our list, let's go to the next one, 3. Let me do that. Let me actually just circle that. 3, okay. So now let's cross out all multiples of 3. So 6 was crossed out. It's already crossed out. We don't need to cross it out again. 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, and 99. So we crossed out all of the new numbers that had 3 as a factor. Okay, so they aren't prime either. So we'll take the next smallest one. We know that doesn't have any factors that are smaller than it. So let's go ahead and circle that. And we know it doesn't, because if it did, we would have crossed it out already, right? We crossed out all multiples of 2 or 3. So if it didn't get crossed out, it doesn't have a multiple of 2 or 3. So let's cross out all multiples of 5 now. And just like before, well, since we arrange them in groups of 10, the 5s follow a nice straight line. So everything that has a multiple of 5 are these guys. And, well, we already crossed out those guys, so we're good to go. Okay, now 7 is our next one. We're going to cross out all multiples of 7 we haven't crossed out yet. So we have 7, 14 we already crossed out, 21 we already crossed out, 28, 35, 42, 49 is the first one that we didn't cross out yet. So let's cross out 49. We keep going. 49, 56, 63, 70, 77 is new, 84, 91 is new. Okay, and we keep going, and in fact that is it. 98 would be the next one, and that's already crossed out. And it turns out that there are no other multiples of any of the crossed out numbers. So what's left, or uncrossed out numbers I should say, so what is left are all prime. 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So they are all of the prime numbers that are between 2 and 100. Again, you could do this with a much larger list if you like. Then you'd pick up multiples of 13. That, I think the first one that you'd pick up would be 143, 13 times 11, and things like that. In fact, you'd pick up 121, 11 times 11 if you kept going, and that you'd cross out that. But between 1 and 100, these are all of the primes, and everything that's crossed out is composite. And, well, the other number is, of course, good old 1 up here.